Today we're doing section 6.3 and we are converting equations from rectangular to polar. So we're going to kind of refer back to the two equations we used yesterday in class. And when I was trying to convert, I would use that sine of theta is equal to y over r and cosine of theta is equal to x over r. So if I wanted to isolate x and y, I would multiply both sides respectively by r. So I would multiply by r and multiply by r. Same thing over here. Multiply by r, multiply by r. So they would cancel. So I end up getting that y is equal to r sine of theta. And over here I get x is equal to r cosine of theta. So I'm not necessarily introducing two new formulas today. It's just the same formulas we've been using. It's just we kind of manipulated them a little in our favor. So at any point today, when we see x and y, these are the formulas we're going to use. So for our first example, we want to convert the equation of x plus y equals 5. So this is a linear equation. If I solve y equals mx plus b, this would be a straight line. And my goal is I want to convert this from rectangular into polar. So I need to get rid of x and y. So we're going to use those formulas I just talked about. So x gets replaced with r cosine of theta. And y can be replaced with r sine of theta. And this is still equal to 5. And I don't really need those parentheses now that I substituted it in, so I could just say r cosine of theta plus r sine of theta. And the goal when I'm putting these into polar is that I want to solve for r. So when I look at this problem, you can see that they both have an r in common. So I'm going to factor the r out. By doing that, I'll be left with cosine plus sine. And if my goal is to get r by itself, I would have to divide both sides by this quantity of cosine of theta plus sine of theta. And we know whatever we do to one side, we do to the other side. So our final answer for r is 5 over cosine of theta plus sine of theta. And now we've successfully converted this equation. So obviously this is an example of an easy one. We're going to do a more challenging one next. So in our next example, we have x minus 1, the quantity squared, plus y squared is equal to 1. So the last one was a linear equation. This is actually a circle. We went over this in Algebra 2. You might not remember it. You also went over it in geometry. So the center of our circle is 1, 0, and that's coming from this information right here. And the radius is 1, and that's coming from that information right there. It's always, the general case for a circle is x squared plus y squared equals r squared, which is an equation we've used all the time in our class. So the square root of 1 is 1, that's where the r is coming from. And anytime we shift this x and y, that's going to affect the center of our circle. So same deal as last, we're going to use this formulas. So this will become r cosine of theta minus 1, the quantity squared, plus r sine of theta, the quantity squared, and this is equal to 1. So we know when a quantity is squared, I have to write it twice. So this is an r cosine minus 1, r cosine minus 1. And again, you could write this one twice. This is an r sine times an r sine equal to 1. So when I multiply these, for the left-hand one, I have to FOIL or box. So if you're a boxer, put these two quantities in the box. If you're a FOILer, go ahead and FOIL. So when I get this answer, I get r squared cosine squared. And if you want to pause the video and try it on your own, go ahead. of theta. Notice the cosine is what's squared, not the theta. My inner and outer terms are going to be exactly the same, so I'll have two of them. So I'll have minus 2r cosine of theta, and then I'll have plus 1. Over here, r sine times r sine will be r squared sine squared of theta, and this is equal to 1. And now I need to do some rearranging. I can cancel these 1's out, so they're going to cancel out on both sides. And I'm going to move this term right here to be next to this term there. So I'll have an r squared cosine squared of theta plus r squared sine squared of theta minus 2r cosine, and now it's equal to 0 because those 1's canceled it out. And these first two terms I can take out an r squared, and when I do that I'm left with cosine squared minus plus sine squared. And I still have this minus 2r cosine. And I know that cosine squared plus sine squared is equal to 1. So this whole quantity right here is going to go away. And I'm going to flip the screen so I have more room. So when that goes away, I'm left with r squared minus 2r cosine equal to 0. And at this point we look at it and we determine what we have in common, and that's an r. So I'm going to factor an r out. So I'm left with r minus 2 cosine of theta. And from here, to set up our two equations, my one equation is going to come from the outside. So this will give me r equals 0. And then this one, if I set that equal to 0, I'll get r equals a positive 2 cosine of theta. So that's because I set equal to 0 and solved. Now, r stands for radius, so this one on the left, r equals 0. So if there is no radius, if the radius is 0, that means there's no circle. So this answer does not make sense. So this is the answer that we keep. So that's all for today. We're going to do some practice on converting rectangular to polar equations tomorrow.